Hello guys, don't worry, I'm still the one, CharlesGPT Tech Talk. But if you can see, I changed the interface of my web app, my math web app. I changed the interface so it will be more cool than the other ones I was doing. So if you have any other thing that you need to be changed in the web app, I'll just work on it and get it done. So in today's course, we are focusing on the course 3. So make sure you have watched my course 1. You have done the quiz for my course 1 and done the quiz for my course 3. And it's in my videos for my YouTube channel. It's on the video. So make sure you have done the quiz for those courses and make sure you have subscribed so you'll be part of CharlesGPT Tech Talk, where I'll be dropping quizzes uh, for programming languages, for preparations for your tests, preparations for your exams. So I'm getting most of the possible quiz and questions being asked in all the subjects, all the topics that we are going to do. So all the topics that programmers take. So I made a web app for it. So no long talk. And this video this week, this course 3, we're going to be focusing on modular arithmetic for computing. So if you have had an idea of modulus, I know that most of us have know how modulus works and many other things are wrapped around it. But the thing is that I think modulus is more confusing than you think, and there are more things to modulus. Even me, I kind of find it very confusing even till now. But it's one of the longest application that took lots of my time to get questions on it, and I might have forgotten some of the answers, but we move though. So I can't basically explain everything. You can read it out and know how to get done by it. But to the ones I can, modular arithmetics or computer or clock arithmetic, modular arithmetic or clock arithmetic. So it's just like a clock. That's how I understand mine. I don't know how you understand your own modulus or stuff like that. It deals with number wrapping around the modulus, essential in computer science. So it's very essential in computer science. If you have heard of a very popular game of programmers, Fees balls, like if anytime it's on 3, it will give like fees. If it's divisible by 3, it will give fees. If it's divisible by 5, it will give balls. Then if it's divisible by 3 and 5, it will give fees balls, something like that. That was the first program that it's made me like programming so much because I I just created something like that and it's now part of me. I can just create Fizzballs program in a twinkle of an eye because I created it multiple times till I became perfect on just that Fizzballs program though. So it's just by it's just step by step. So for integers a, b, and positive n, a. So what this means is that this triple equal sign means that this this a sorry, this a modulus this n yield, okay, it explains it here, means a and b yield the same remainder when divided by n. So a and b yield the same remainder when divided by n. So remainder computation, so the same thing, we have this dot means multiplication times in this and this in modular in programming, I mean to say. So we have key properties, addition, subtraction. So you can see how we added it. So a plus b mod n equals, you join this together and find the mode right here. And multiplication, still the same thing, join it together. This dot means to multiply and show the mode right here. And the same thing as this exponentation, stuff like that. Then modular inverse, and for this modular arithmetic for computing, it's not must you know everything. It's just that I just try to make sure that I covered every single thing you need to know on modular. So if you start your quiz and you're able to click like a very 30 out of 30 questions, you are very good in modular. Because me myself, I will not even, like, even without you know knowing the answers and stuff like that, I will not be able to get like a full 30 out of 30 and this stuff. So Modular inverse. So we have what they're calling an inverse modular. An inverse of a modular n is where a times x is triple equals 1 mod n exists if GCDAN equals 1, found via the extended Euclidean algorithm. So the places they use modular is in applications called cryptography and error checking, bank validation, stuff like that, computer science, hash tables, cyclic buffer, and randomization. So I did research on these notes. So these are the whole things you need to learn on understanding modular. So you just quickly start your quiz. If you go to my, it's on the description page of this video. So go to the description page, you see the published GitHub. So you start your quiz and it generates your own 30 random questions, so you can work with that. So if I start my quiz, you see this. I also made the interface to look pretty good and stuff like that. You see the hover function and the stuff like that, with the transitions and So compute this 7 raised to power 4 mod 5. Okay, I think it's 2 or something. I don't know. Incorrect. Shoot. Oh, they got me. Incorrect. So incorrect. The correct answer is 1. So yeah, 1. I thought of it. So what they need us to do here is 4 raised power 7 raised power 4 will be, I think it will give you 2401. So 2401 modulus 5 would give you 1, because 2401 will give you something remainder 1. So in modulus is just the remainder they're calculating. So the answer is 1. So go for the next question. It gives us a very detailed solution right here as well. Don't mind my voice though. So question to the compute 15 times 27 mod 10. Mod 10, I think it's 5, because I was the one that did the question. So I think it's 5. Let me check it out. Okay, correct. So you times, this one is pretty much easy. You times 15 times 27 will be 405. Then you find the modulus. 405 divided by 10 is 40 remainder 5. Thus, the modulus 40 remainder 5, since modulus works with remainder, the answer for the question would be 5. So that's how we got 5 for this. So I don't need to explain much. I've already explained it in my solution. After you get your answer, even if you get the answer right or you fail the answer, it will give you a very detailed explanation. So I don't need to explain it very, very well in this video, but I'll just briefly explain some things though, so it won't be that long since it's math. If I just have like time or enter another page that will be solving the equations, it will take time. So make sure you practice, take your quiz, learn more, and as they say, no knowledge is a waste. So does the inverse of 6 mod no exist? No, it doesn't exist. So that's the answer. So inverse need to like give a modulus of 1 or something, GCD of 1. So this one would be I think 1 as well. Correct. Okay, cool. So this one would be this, I think. Let me see. Cool. So that's the answer for this. So it gives you why the solution is that. So the next question, this one would be 7, because 47 divided by 8 is 5 remainder 7. So the remainder is 7. So the answer is 7, because that's how modulus works. It just gets only the remainder from the question. So next, it gives you the answer and the solution. You see a brief but detailed solution. That's how I just tried to make you guys understand more on this modulus arithmetic for computing. Next question, we have this. Okay, what it means is that 5 mod 3 is equals to, because 5 divided by 3 would be 1 remainder 2. So the answer is true. So we submit. So you see how the thing works. It gives you like an exact solution for this. So next one, we have this. Yeah, it's true, as we said. Don't worry, in my next improvement, I think I will make something more cool. So you guys should just bear with me. So next one, I don't know if this interface is that good. Oh, Still cool though. So 13 mod 5 would be 5 divided by 13 would be 2 remainder 3. So it takes only the remainder. So that's the correct answer for that. So it gives you divide 13 by 5. 13 divided by 5 equals 2 remainder 3. Thus 13 mod 5 equals 3. So next question we have 4 plus 6 mod 5 would be 0 because 4 plus 6 is 10. Then 10 divided by 5 would be 2 remainder 0, no remainder. So the answer is 0, I think. You see, cool. Next, questions 11 is A plus B mod this. No, no, no. Only, wait, I don't know what I gave us the answer for this. No, 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 no. Always, always. Oh, always, always, always. How it's okay. Yeah, it's true. It's always. It's always. Oh shit. So for the next question, we have what is the inverse of 3 mod 11? The inverse of 3 mod 11, I think it's inverse of 3 mod 11 would be, let's just say 4 or something. Next, correct, 4. So it gives a solution and I just keep to it. So can exponentiation be reduced mode and exponentiation? Very long sentence. Exponents, that's all I know. To exponentiation be reduced mode and can it be reduced? Let me just say yes. Correct. Next question, what does A this? Okay, this is pretty much cool. So it means A modulus n is equals B modulus n as well. So cool. So it gives you the same answer. So for the next one, we have 15 times 27 mod 10. So I think it's 5. So let's check it out. Correct. So you see, compute 15 times 27 equals 405. Then 405 divided by 10 equals 40, remainder 5. So that's it. It just takes the remainder in. So does the inverse of 6 mod? No, it doesn't exist. You can't inverse this. It needs to be like mod plus 1 or something. So next question, this would be 19 divided by what will give you a remainder of 1. So 19 divided by 9, because 19 divided by 9 is 18, remainder 1. So that's the answer, 9. You see, and it gives you a detailed solution there. Next question, solve x plus 5, this. So what we need to do is x would be 4 because 4 plus 5 is 9. 9 divided by 7 would give you something remainder 2. So I think it's 4. Cool, 4. Don't worry how I'm getting it. I'm not that quick. It's just that it's my question, so I'll probably know the correct answer. Minus 1 mod 7 equals 6. Minus 1 mod 7 equals 6. True. True. So it gives you an explanation here, so no need to explain it. I just give you like a brief explanation for everyone. So if you go to my web application, you take your quiz, anything you get, it gives you an explanation for your question, for the solution to your question. So next one is this valid? Is this? I think no, but let me just say yes or something. Okay, it's correct. Yes. Yes, okay, it's valid. Oh, okay. So the next one, 18 mode 9 would be 0. Okay, this is pretty much easy, 0. So 18 mode 9 would be 0. So the next question, does 3 have a modular inverse mode 10? If yes, what is it? I think it's 7. So it gives you like a detailed explanation for it right here. So the next one is 4 times 6, 24 mod 5 would be 4 because 24 divided by 5 would be 4, remainder 4. So I think is the answer correct. Next, so 18 minus 7 mod 5 would be 18 minus 7 mod 5 would be 11 divided by 5 would be 3. Oh no, sorry, I mean 11 divided by 5 would be 2, remainder 1 or something. Yeah, 11 divided by 5 would be 2, remainder 1, I think. Okay, yeah, Cool. That's it. So we are just working with modulus is working with the remainder. So if you remember that. So okay, there's 6. There's 6. I think we have seen some equation like this before, but similar to this though. 6. So for the next question, we have a plus b mod n, a mod n plus b mod n. It's false because I think you need to have something like in square braces here. Yeah, I know it's false. You have this square braces here, then the mode outside it again. Okay, so 17 mode 1 is anything mode 1 is always 1. I think it's 1 or 0. 1 or 0. I think 1, yeah, because 17 divided. No, no. 0. I think it's 1 or 0. What's the correct answer for this? Let me try my luck with 0. 0. Oh, it's correct. So it's 0. I thought it was 1. So anything mode 1 is equals 0. So for the next question, we have 47 mode 8 would be 7 because 40 divided by 8 is 5. And 5 is 47 divided by 8 is 5 remainder 7. So the answer, we are working with the remainder, so the answer would be 7. So submit correct. Next, an even number, this, I think it's 0 or something. 0, let me try 0, correct. An even number, this 0, it gives you an explanation for this. So 9, okay, so what would divide by 47 that will give you a modulus of 3? It would be 40, it would be 11 because 11 divided by 44 would be 4 remainder 3. So I think it's 11, yeah. So you see that. Next, okay, so you see my results are out. It said quiz results, your score 28 out of 30, genius modular maths master. I'm the one that created it, so I'm not a maths wizard or anything, but I'm very good in maths and I tutor maths as well. So but in this video I can't make it that long. I just want to tell you people about that our course 3 quiz application is out and ready, and I'll be posting it in the description of this video. In the description of this video, I'll be posting the link to get the quiz on the description of this video. So make sure you check it out and test your understanding because it generates a random question for you guys as well. So and I'll make sure to improve my interface in my next video recording in the interface of my web application to make it more beginner friendly and very adjustable. So if you need more improvements, just let me know in the comment section, and also drop your scores and your comments you received. For mine, I received Genius Modular Math Master. So anything is your score and your destiny, and tell me a topic that you find confusing, and I'll try my best to create an application for it and explain it very, very well. So make sure you take the quiz and make sure you like, comment, and subscribe to this channel, and watch out for our next maths course 4. Yeah, thanks. Love you guys.